Had something very unfortunate happen here. This compressor, this is the inverter compressor on a VRV3, is shorted to ground. But as we were getting in here, there's a bunch of oil in the bottom. Ended up finding the leak right down in there. I have on earphones so you can't hear what I'm hearing, but it sounds just like a jet engine right in there. Now that spot on the coil, that wasn't like that. Let's see if I can get it in focus. That spot in the coil wasn't like that. I moved those fins to just mark where it's at because I think we're gonna have to uninstall this coil and try to fix it. I have fixed leaks in these before. The copper is just paper thin. It's very difficult repair, but I'll kind of show the process and we'll see what we can do. Apologize, it's very windy today, and I'll try to do the best I can with filming, but this is quite a job here. So I'm gonna get a before and then an after, because it's really hard to see into these VRF units because they are just crammed with stuff. But we're about to strip this thing down about as far as you can go, so that'll be kind of interesting. I'll get to show some of the internal piping and some of the stuff going on inside of them, and it's a lot. It's a lot. I mean, there are tons of EVs and solenoids and all kinds of crap in these things. If you've ever wondered how many screws it takes to get to the guts of a VRV, it's a lot of them. Now, it's a little hard to tell, but I think the leak is in this line here. But unfortunately, and when you're trying to fix a leak on a coil, you just got to cut the fins back, and it reduces the capacity, but almost a negligible amount. I mean, it's not enough to matter really. But I'll cut this out first and then move down here. But I could have sworn I saw the brunt of the bubbles around this area. So I'm gonna cut in the front, in the back, and then pull these fins out with needle nose. Got the fins off, and I don't see anything really jumping out at me as far as a crack or a hole. So this one at the bottom is always suspect, and we're going to start peeling that one back. Now this copper is just paper thin. I mean, I could probably grab it and just crush it with my fingers. It's very difficult to braze. Unfortunately, I did have to go through the effort of brazing in a tap, use a shark bite there. Either way, I got to redo this pipe. But the leak is right underneath here. Man, it was hard to find. And it's more like a crack. All right, so it looks like, I'll try to get out of the light, there's a little split that's right there, and that's where the leak was. Man, that was hard to find, because even though it looks like it's open, it's only open because I got it under pressure. It was not leaking at all until around 200 psi. Cracks are sometimes really hard to find. They can be very intermittent. Coil held pressure overnight perfectly. Ideally, I would like to put more in there, but we're running kind of low on nitrogen at this point. But so brazing over top of cracks is not my first choice, but in this situation, this is one of those things where you have to do what you got to do to get the customer up and running, and then they have the option of replacing the coil. But I just laid a fair amount of braze over that, which will probably be fine because it's such a small crack. I was touching up a few other areas. As I said, you know, this copper is like paper thin, unbelievably difficult to braze. There was a second where I had my torch. I was brazing, touching up a few suspects down here, and I had my torch up in this area as I was looking at the braze and burnt through this on accident. It's just, it's horrible. But what I did was I created a saddle out of a split piece of 3/8 tubing, and I've got that brazed around like a patch. This right here is a look at the future. Obviously it's already here, but we're going to be seeing more and more of this type of thing in the field. I'm going to flash a picture up here and then just talk about it for a bit. Okay, so you saw that picture. That was a PTAC unit. That's a service call I had to run last night. Imagine trying to take measurements on that board, work on that with zero service information. Yes, I was able to troubleshoot it. Yes, I fixed it out in the field because I am familiar with these and stuff, but that's a PTAC, okay? This stuff is coming fast, and look at what they did there. So they had, you know, you have your standard PTAC footprint, right? What they did was they created a high efficiency unit to fit in that same standard PTAC slot, and so everything got crammed in that cabinet. So imagine working on that in the night. You can't even access the board. What it was the main board in the back, which is going to be controlling a lot of your power, obviously the inverter and stuff like that. I was missing one of the feeds, the power feeds into the main logic board. So had to rip that board out, take another board off a donor and put it in there. You know, this field is going to be rougher and rougher to work in, as the automotive field has been. But one of the big differences is, in the automotive field, manufacturers have traditionally been very good about service information. Now, they are very good on VRF, but when you're dealing with that Chinese POS PTAC, service information, very hard to come by. Now, I didn't get online and look, you know, I probably will today, just check it out, see what's there. But the wiring diagram, they didn't even define, like, you know, there's 4 or 5 different thermistors. All they do is call them TH. They don't even tell me what they are so that I can look at them. Nothing is clear. I mean, it's just horrible. They're using 7 millimeters like these old pieces of crap, you know, instead of your standard quarters, 5/16. But my point is, what's happening is that these shitty manufacturers are trying to jump into this technology, and it's going to make things kind of rough for us. But this is a good field to be in. Lots of job security, you know, great field to be in. It's only going to get better as far as job security and all of that, and potential for profits for companies. That's only going to get better as time goes on. So here's a look inside an inverter. So on this one, there's one standard and one inverter, unlike the 4s where there's 2 inverters. It's really easy to see now because the coil's gone. I want to point out a few things. I'm not going to go through everything, obviously. And to be honest, you know, these, you have a piping schematic, just like a wiring schematic. That's how intricate and complex all of this tubing is. But if we just want to take a look at a few things, this is an oil return cap tube. These sometimes blow out. They're responsible for a lot of refrigerant loss. They can also get clogged. The way that you check these, so we're going to have oil coming up in here and constantly dripping into the suction line, is that you're going to end up with a temperature difference upstream versus downstream. So you're going to be warmer down here, and I've found, you know, somewhere between 5 to 15 degrees is what you can expect. This also has there's also a way for this solenoid to open and send oil straight into this. Now, this is not an accumulator or a receiver, although it acts like one. What this is really for is refrigerant storage. That's kind of a little bit of a different function, even though it's very similar. You can see it's called refrigerant regulator. But on a system that's very, very highly variable with capacity, you have to have a way to trap refrigerant so that the system can run under really various loads, and then you can release it back into the system. So this is similar, but it's very like solenoid controlled. It's controlled with an extreme amount of logic. It's not just like a dumb receiver or a dumb accumulator. Everything in this unit is smart, so to speak. Even though most of the time it acts dumb. We have lots and lots of temperature sensors. Let's see, what else can I get into? Obviously reversing valves. I believe there's 2 over there. Again, you'd almost have to see a schematic to really get into this. This is the main EEV on the inverter side. It's the power head, that's the valve obviously. Then this is a subcooling EEV, so we can use that for advanced refrigerant control, similar to that. Oh, what else? We got lots and lots of solenoids. I have not traced those out, but let's see. They have to do with the refrigerant and oil regulation. Okay, so a little look into what's coming if you're not already working on this kind of stuff. This is going to become the norm. I was just reading an article about how Washington State has passed regulation where new commercial buildings can no longer use natural gas as a heat source, which pretty much mandates these, because I really don't think these commercial buildings are going to be built with electric, although I suppose that's an option. Got a new tube on the little squiddy there, and let me talk about something real quick. So if you happen to have a leak up in here, it's very common to get leaks right at that plate. The best way to handle that is go ahead and sand this area down really well. You know, push the plate back, you know, and forward. Just try to get as good as you can in there. Coat this entire area with flux, and then take safety silver and actually braze this ferrous metal, this steel, right to the copper. You want safety silver for that for sure. You don't want to use a braze that's got phosphorus in it, and you want to use flux, but that is an extremely effective way to fix leaks on coils right here at this spot. I almost forgot to talk about something else. And you know, in general, there's always more than one way to skin a cat. You know, I get comments on, hey, do it this way. It's like, yeah, there's always more than one way to do something. There's always more than one tool to do the same job. But anyways, another solution to this problem is to just take a circuit completely out of the coil. So just cut these, cap it on both sides, and just take that completely out. And you know, to be honest, that's probably not going to affect the efficiency enough to really matter, but it just kind of bothers my OCD. I prefer to try to make the repair and leave the circuit in place. You know, it's just my preference. But yes, would that be a quick, easy repair on this? Absolutely. Again, always more than one way to skin a cat. Semi truck is probably the best way to skin a cat when you really get down to it. But right? As far as getting this coil in and out, like pretty much all coils, a lot easier than it looks. We just got 2 connections here. Now taking the unit apart and everything else, pain in the ass, but actually putting the coil back in place and getting brazed in, not too bad. Pretty much finished here. Still need to do a few things. I'm going to put some silicone down there to stabilize those pipes so they don't continue to rub on that plate. A few other little things, but I'm getting ready to start this system up. I am going to talk about how these inverters work. I did a short on that, but I'll show it again just because I have the stuff out. Now, what I'm doing here is I'm connected into F1 and F2. Those are my comm lines. And the way that the setup I like to use is I have a magnet on my cable and I put it up higher here. If these happen to detach, and I've found that the small alligator clips by far work the best on these little screws here. If they happen to detach, I like to have the cable up high so they don't happen to drop into mains. That would be very bad for the old service checker. But I've got my cable up there just running back to the service checker. So let's take a look at what we have. Here's the old piece of junk right here. Now I've used the new one, and to be honest, I had high hopes, but it's really not much better. The software is horrible, and I'll get into that. On the new one and the old one, there's like a couple things that the new one does that are kind of nice, still the same crap software. Okay, here's a look at the monstrosity called Service Checker. This is Daikin software for the VRV units. The VRVs are just a brand of VRF. This is by far my least favorite software of all the VRF softwares. I have a few things blacked out here in very crude fashion. It's because when you save controllers and you save maps, it displays customer information. Just names and stuff, nothing specific. Check this out. I can still select before Windows 95. For the love of God, I wish they would update this software. But anyways, selecting the COM port is very important. Otherwise, you get an error. Here is the equipment map. Now, I'm on AirNet 1 because that's the AirNet address for this unit that I'm hooked up to. You can see the AirNets change as you cycle through. Be on 1. Now you see 3 outdoor units. There are not 3 outdoor units on this system. I have no idea why they did this, or why they did a lot of things for that matter. But what this is there's 3 files related to the information that's in this outdoor unit. Yes, it is strange. Yes, it doesn't make sense. And that's all I can say about it. You'd have to talk to the software engineers to even begin to try to understand why they did some of this stuff. So these are all AirNet numbers here. Now the newer Service Checker will show you group number, which is very, very handy. I for the life of me, I can't understand why that was not a feature from the beginning. But I happen to know that these units are, well, obviously you see where they're off. When they're gray, it means they're off. But these units are right here. Now, it's easy in this case, but if you have a lot of units that are off, you get the group number, that like the group address from the central controller, and then if your address is like 1-0, that's this unit here. Okay, and then that unit would be 1-3. You know, it just goes down the line. So the AirNets you can also pull off of the nav remote. That's what the apprentice I'm working with now is doing. Also programming some stuff that was set wrong during commissioning, compressor killer type stuff. Then you have all of this data, which is just, you know, you can graph things and stuff, but what I would really love to do is be able to select the data that I want to see and just see that. I hate having to scroll through all of this crap to look for what I'm looking for. Now you can go in here and select, like, here's I1. Now I1 is going to refer to this. Now why these are not in order, you know, don't ask me, but your I1 is always going to be the first unit here, and then this is 2, 3, etc. So again, not a full training video. I'm not going to go through everything and how to go through this, what they mean, how to troubleshoot stuff. That's just not something I got the time or energy to get into. But I'll just point out a couple things. And it gets kind of goofy with, where am I? Now remember, we don't have 3 outdoor units. So even though we have 3, why is it doing that? Just freaking there. Even though it looks like we have 3, this is all just various bits of data on that one outdoor unit. A couple of things to pay attention to, just as examples. Your target condenser and evaporator. By default, these are highlighted. I normally highlight this along with, see, our actual, which is down here. Here's actual pressures. Okay. Discharge temperatures, that's really important. Now you'll note the other thing that's very annoying is you kind of have to know what to look at and what not to look at. See, we do have a standard compressor, but we don't have a third standard compressor. So there's all kinds of just trash data that gets into this list. But just a brief look, I figured I would just show that. Might be interesting to some people, but this is how you work on VRF equipment. They all interface with the computer, and this is one of the main troubleshooting tools you're using. So the days of just going up with a meter and an 11-in-1, those are gone. At least on this equipment, long gone. Now you can still, not saying you still can't do stuff with the meter, but to really work on VRF systems, you have to hook into them with the computer. Okay, this is kind of cool. Hopefully you saw that, but my inverter just changed frequency. You saw these waves get closer together, so it's picking up the frequency as the load is increasing. Now, one thing that's interesting about inverter, there it goes again. Let's see. This is the new Picoscope software, and I have not gotten used to it yet. Let's see. Okay, here we go. I just added frequency. So the interesting thing about an inverter compressor is you might think that it's running on some kind of weird waveform or DC, because the boards do produce DC, but it's not. It's AC. The boards take in mains, and then they convert that to DC, and then from there the board can use that DC to make very, very finely tunable or finely controllable AC frequencies. So that's all the inverter is doing, and it's running wide open now because you know, this thing's been down, and it's under really high load now, so it's wanting to run wide open. And you can see we're kind of like at maximum amps in here. In fact, I can add a math channel that'll show amps here in a minute. Well, I could just add it in as a measurement, but we can go RMS. Alright, so there. Now this RMS reading is going to be a little different than what a meter would take, for example. But so we're slowing back down. Might have kicked on the standard. The way these work is they will the inverter always starts up first, then it will go to max capacity, and then if it still needs more capacity, it will kick on the standard. When it does that, the inverter drops back down. Okay, and then as the unit gets closer to satisfying, standard will cut off, and the inverter will then shut down. The inverter is always the first to cut on and the last to cut off. I'll show one more thing on service checker here, and then I'm going to go back to the scope. I think I misspoke about the current. It's hard to watch this through a screen, like my filming screen, but I'll get all that straightened out. Anyways, so I typically graph more than this, but just to keep it clean, here's our target. and here are the actuals, and that's a good thing to look at. Now you can see this kind of coming up in steps, and to be honest, the inverter kind of comes up in steps, so that's kind of interesting there. These things really do have a mind of their own, and you really can't overanalyze it too much. Like, for example, this hasn't run anywhere near long enough for these to be matching, but once everything gets settled, if the refrigerant charge is right, they're reasonably close. There's some caveats in there, and again, you have to really be careful not to overanalyze what you're looking at. But these things are pretty good about controlling pressures, and that's what makes them difficult to diagnose refrigerant wise. You really can't look at these pressures. They're so good at controlling pressures that they can control pressures pretty well, even missing a lot of charge. I've seen that quite a few times. So there are other things in here you need to look at to determine the refrigerant charge. But this one I know is correct because we have weighed it in according to the submittal. All right, let's keep going. So here I put in a math channel for the RMS, and there's a bit of a discrepancy, which is what I thought. Now, which one is more accurate? To be honest, I'm not sure. I mean, you would think that the math, the just straight integral of the curve, etc., is going to be more accurate. I'm not sure, but not that it's a huge deal, but that's what I was referring to about the current. For whatever reason, I've just noticed that there's a difference there. Phone ran out of storage and cut off, but these things are quite incredible, and yes, they can run pretty well with the doors off. I'm not messing up things too bad. I mean, everything is variable speed, so the unit has unbelievable control of pressures and everything. But this is a unit running wide open and very quiet. In general, just VRF technology is unbelievably impressive. I love working on this stuff. It's the main logic board, compressor inverter board back there, fan inverter boards back in there. There may, of course, your standard has a whole other set of controls. Very, very impressive. Here, this bunch of wires, those are solenoid controls. I mean, there is just a lot of stuff going on here. These are sensors. This thing is just jam-packed with sensors, and some of that's going to be the EEBs, which, I think that's a connector for one right there. Anyways, very cool units.